So in this part we are solving the Bayes theorem problem, and you can pause the video and read the questions. And in such questions we will be given some events, or can be called as independent events, and we'll have a condition. So here we have the events that the 60% of these voltage regulators will come from the supplier A, and 30% of voltage regulators from B, and 10% remaining from the supplier C. So these will be the events, and this will all add up to the 100%. So there will be no other events, and the events will be limited by number 3. And we are given these conditions for each events, so that the 95% of voltage regulators from A, 80% from B, 65% from C will perform according to specifications. So this means that this is some kind of guarantee or something written on paper that the voltage regulators will perform according to their guarantee. So this will be the conditions for each of these events. So I have listed down the events and their probability. Event A 60, event B 30, event C 10, since these are the independent events. So and the condition, so I have denoted the condition by A and the dash. So this will be the percentage of voltage regulators that perform according to specifications. So this is the universal case that will apply to each of these events. So here I have represented the problem diagrammatically. So here you can see these events: A with 60%, B with 30%, and C with 10%. So here we have been given these condition denoted by this A dash. So the probability that the voltage regulator A will perform according to specification under that event A. So this will fall under that event A, because we are dealing with the voltage regulator A. So we have to we are checking whether the voltage regulator A will perform according to specifications. So this is the probability. So, and similarly here for the conditional probability of this event B, under this event B will be 80%, and the probability of the condition under this event C will be 65%. And so we have to find the, currently we are doing this number 2, we'll do the number 1 part later on, number 2, and we have to find the probability that the voltage regulator that performs according to specification that comes from B. So the event here will be that the voltage regulator will come from the supplier B. So this is an event. So we need a condition. So that condition will be that the voltage regulator will perform according to the specifications. So you can see here the condition, universal condition right here, that the percentage of voltage regulator that perform according to the specifications. So this is the condition A. So I missed the A and the dash here. So if I break down this into the uh, numerator and denominator, uh, like the example here, so you can see here we have these probability of these independent events, like the B, A, and C. So this can be written directly as 60 for A, 30 for B, and 10 for C. So we have done the independent event part. Now we are going for the conditional probability part. So in the conditional probability part, we can see the condition. We have to find the probability of this condition under the given event. So for the event B, under this condition, A dash B will be mm, the 80%, and the um, probability of this condition under that event A will be 95%, and the uh, probability of that condition under that event C will be the 65%. So we'll put the values in this equation, and we'll get the answer as 27.42%. So we can say that the probability that the voltage regulator that will perform according to specification that comes from B will be 27.42%. So for the number one part, where we have to find the probability that any voltage regulator received by the plant will perform according to its specifications. So this is the classic case of the total probability. So we'll take this denominator and we'll put it here and put the values, and we'll get the answer. So this is the solution for this question 1.